All right, so welcome everybody. Thanks again for your patience for this late start. But I heard a great conversation the entire time. I had my AirPods in while I was running around, making sure that I was geeking out with radar. I'm an ex-weather guy here, so but that was a great explanation of the reversing string and using those string methods to help us come up with solutions. And it was fantastic. So thanks, Michael, for being on the spot and doing that. And thanks to Chad for kind of holding it down while I was taking cover for a bit. But yeah, so we're gonna roll right into lesson 3. And if you notice, like some of these exercises have kind of dove a bit into concepts that you really haven't learned yet, but that's okay because that really, in the boot camp, it's going to happen too. You're going to have to start looking things up, and that's why I have these resources here for you to look at. The Python resources, or you can Google, getting started with that now and trying to find ways to accomplish things, looking at string methods or list methods. You can do that now. You don't have to wait for the lesson. But we will set aside time in the lesson to really kind of do a bit of a deep dive into it. So, so welcome to day 3. And today we're gonna explore conditional statements, which we already saw in the exercise, some if-else statements, and it ties right into that truthy Falsy logic and using those Booleans. And then we're also going to get into Python functions, which is an extremely important piece of learning how to program, because you're going to be writing a bunch of functions. Really, all the programs are just a bunch of functions working together in a machine that does something, the big thing that you want to do, the big thing you designed it to do. And so that ties nicely with our problem solving concept. So, you use a function to solve a small problem, you write more functions to solve other small problems, and then working together, they solve the big problems. And so that is, software, that's writing software 101 and just structuring your code and making it more organized and reusable. So, so let's just dive right in. So we'll start with some Boolean values and expressions. And again, I have some links here you can go to and take a look at. But we talked about these already in the data type introduction. A Boolean can be 1 of 2 values. It can be true or false, 1 or 0, off or on, right? But in Python, it's true and false with a capital T and F. If you notice those words show up purple in my IDE, they may show up a different color on yours. But with the capital T, you gotta make sure it has the capital T for it to actually show up as a true Boolean. And so we can define those just like we can. We can write the word true or write the word false, but we can also use it as a result of an expression, which is typically what we're going to do. So any Python object can be included with those Boolean expressions. So if I have a variable assigned to a value of 35, then if I evaluate that and say x is greater than 40, it would evaluate to false. So you can take a look here. If you can take a look at the type of the Boolean here. If I run this type method again, this is a Python included method. It shows up as green and underlined. If I run this, it tells me that true is a Boolean. I can assign Booleans to variables. So if I run that, now I called the Boolean, it is false, and it stays false until I redefine it. And just note that true and false are capitalized. So the lowercase true and lowercase false, they don't mean anything. I could define a variable called false lowercase, but that would be typically bad practice, because you don't want to use those terms. It would just be confusing to somebody else reading your code, and it would probably confuse yourself if you put that code away and came back to it, and a couple months later you're like, what's true? What is this? And so, of course, if I run this here, it says lowercase, it has the little yellow squiggly underneath it. The ID is telling me something's wrong here. It says false is not defined. If I were to new with Python, I'd be like, why is false not defined? That makes no sense. You have to remember, oh yeah, it's capitalized. And so I do is just change the F, and now it becomes a true Boolean, and it looks all pretty with no squiggly line. So comparison operators. So Boolean values can be created with Boolean expressions. And these Boolean expressions, we want to spend a bit of time on to really make sure we understand these. And not only that, but also combining comparison operators. We're going to get into that. But Boolean values can be created with these Boolean expressions. And the first type, of the first type we're going to look at are these comparisons. So we have, we have 6 of these here. And if you remember, when we assign a variable, like when we do it right here with, the Boolean here, and we're assigning, we're using a single equal sign. That's an assignment operator. When we're trying to do a comparison, we want to use the double equal. That means it's equal to. So when you write that out, you're making a statement. You're saying, hey, Python, down here in this example, 23 is equal to 32, which we know is not true, right? And so Python's going to say, no, that's false. And we can use these in any comparison. We can do all sorts of stuff with them. So here, we can also define a comparison between 2 figures as a Boolean. So I can say, hey, Python, 450 is less than 350. And Python's also going to be like, no, that's false. And now Boolean 1 is equal to false. And it will always be equal to false until I change it. So this is just like in math class, but what you're doing is you're declaring a statement, and then Python's evaluating that and giving you the result of that comparison operator. Again, when you define variables with this single equal sign, so here we have number 1 is equal to 8, and then number 2 is equal to 6. We can then just use the variable names. And we saw that when we did the dinner bill calculator. We did that with that dinner bill calculator, where we wanted to assign everything to variables to keep our code clean, so we don't have to change it in one spot and not have to change it in several. So that the clean code writing, there's a term for that as well. It's called keeping your code dry, and that means don't repeat yourself. So if you find yourself writing something or reusing a portion of code over and over again, you may want to think about extracting it and putting it into a function that can be reused then versus writing it out a bunch of times. And we'll get into that when we get down into functions. We'll explore that concept a bit. So Thomas says having trouble connecting to the code space.
I just fixed it. I'm good now. I just 'cause I didn't use it yesterday, so I was like, "Whoa, wait a minute, how do I, get back into it?" And
Okay.
okay, so it looks like it's running now, and I can edit the fields and stuff. So yeah,
So you're enjoying code spaces, right? Is it a win? Do you like
I like the Jupyter notebook format
Cool.
quite a bit. I don't know quite its relation to code spaces, other than it's like a VM or whatever that you connect to. Is that proper terminology? I'm not like
Uh,
super up.
so a code space is really just a cloud, like a cloud instance, container
Yeah,
instance, and then it has predefined software already installed. So it has Python, all the main programming languages, but really then they just, they have VS Code in there, and then that's it. It's like a bare bones Linux machine that's disposable. And then whenever you're done with it, after 30 days, you haven't done anything, it just disappears. And so uh,
unlike AWS instances where
it
I think
it's
you've
an
shut it.
AWS instance. That's exactly what it is.
Oh, okay.
Yeah. Um, so yeah, it's really cool and it makes it easy to do stuff on your browser. That's the best part. So um, moving on. So we have the comparison operators. Moving on, we're going into membership checks. And so membership operators, they are, 2 words. We have 2 terms, in and not in. And really what we're doing is we're just going to see if something is inside of some sort of collection. And so when we think of a collection, we can think of strings. We can actually look, we could say, hey, is this small substring inside or in this larger string? And if it is, it'll return a true. And then you can use like the find string method to find the index of the first occurrence. And you can use that to further extract something out of your string if you want to. But the operator, you have the operator in, it checks the left side of the expression is contained in the right side of the expression. So in this example, I have a St. Louis blizzard years, and keeping it weather themed for the day. But I have a list of years here, right? And I want to say, hey, I want to state 2017 is in St. Louis blizzard years. And so if I do that, no, St. Louis did not have a blizzard in 2017. And so that's what that is. So it's going to check through the entire thing, behind the scenes, going to iterate over it, and then see if it's in there. If it's not in there, then it returns a false. Really useful when you're looking at big collections. It allows you to do a quick check before introducing other logic that may fail with an exception. This just gives you a simple true or false. So you can just check to see if something's in there. If it's not, move on. If it is, then do your further logic. So you can have a tree like if else statement to do that. Next, we have logical operators. And so logical operators are how we combine other statements. So like these comparison operators or these membership checks, we can use logical operators to kind of combine two or more together to come up with the final answer, to improve or to make our logic tree a little more complex if we need to. So of course we have and, or, and not. So those are pretty plain language. That's the beauty of Python. It makes it really easy to use. And in JavaScript, you have like the double ampersand or the double pipe symbol, the vertical line to check ands and ors. But just remember with these, the and, you have to check if two statements are both true. So when you write this logical operator, it'll only return true if both of those statements are true, or will return true if either of the two statements is true. So one could be false. It doesn't matter which one, as long as one of them is false, it'll return. If one of them's false to the other, as long as one's true, it'll return true. And then the word not will negate the value of whatever Boolean statement you're saying. So if you are checking to see if something's not in a not in a list, then it will negate it and flip the true or false on you. And that could be useful when doing some comparisons. So these logical operators, they work like they do in plain language. So I have a black dog and I have a brown dog. That's only true if you have both a black and brown dog. Of course, if you say I have a black dog or a brown dog, that kind of opens up possibilities to having a black dog and a red dog, or a brown dog and a blue dog. Both of those statements would still be true because you have one of those, as long as you have one of either color. And so let's take a look at this here, make it a little more, kind of show an example of this. We have 10 greater than 8 and 23 is less than 25. We present this to Python and it's going to say, yes, true. Both of those evaluated true. So that one's true. That one's true. The entire statement is true. Here we have, 5 and 2, 3, 4, 5 in this collection, this list. Or the string W in this coordinate, we have 1, 2, 3, 4, 5, 4, 5 W. So this is also a collection. So remember, the list is a collection. A string is also a collection of characters or a sequence of characters. If I run this, it's also true. I can then say, well, how about 9 in here? What will this evaluate to? Anyone?
It was baseball. My apologies. I had mic
Maybe
muted.
true.
That's true.
Yeah. So if I run this, it also evaluates a true, even though this is false. This one still evaluates a true. Therefore, the entire statement is true because I used or. Of course, if I change this to and I run this, now it's false because this one is false. So Python actually does these in order. So it'll check the first one. If it has an and statement, it'll check the first one. If that's false, it won't even check the last one. It'll say false because it's already false. So put that back here. Now that will value to true again. Okay. And so here we look at this one. Now we have that negating value, the not, and we're saying Boolean 2, we're going to assign a value to the result of this statement, right? So we're saying, hey, we're saying 4 equals 5. That's false, but we're saying it's not the result of that, so it's going to be true. If I run that, Boolean 2 is true.
So I just sorry.
Go ahead.
Oh, I switched it to a not equals or whatever, the exclamation point equal sign for something about false. That's right. I'm actually losing track of the logic in my head.
Okay, so you just want to make sure you kind of still think of that order of operations, right? So start here. 4 does not equal 5. Is that true or false?
False.
That's
That is
That-
not
that's true. It doesn't equal 5, right?
Right. So this by itself evaluates to true. Then I negate that statement.
false.
Oh, I see. So that's why I return. Okay.
Yep.
Cool.
And so this is like a quick little example here. And it's easy to read these. You can read these pretty easily. It's like, okay, 9 and 2, 3, 4, 5, or W, and this coordinate has a W in there. Sweet, I can see that. Okay, it's easy to read, but you got to be careful with Python when you write these, because you have to make sure you have a complete Boolean expression either side. And the example I have here, if you think about those St. Louis blizzard years, right? I have 2014 and 2018 in St. Louis blizzard years. I'm going to run that. And I'm going to print that because I've had that little bit last minute. I'll run that. Okay, so it says true. 2014 and 2018 in St. Louis blizzard years. Okay, run that. 2014 in St. Louis blizzard years. That's false. But 2018 is in St. Louis blizzard years. And so you can read this, and you would, as a human reading this, you'd say, yeah, is 2014 and 2018 in St. Louis blizzard years? Well, and it says yes, like, oh, cool, it's true, right? Because this could be a list of several hundred years. But it's not true. 2014 is not in this list. If you take a look here, they're in order. 2014 is definitely not in the list. And it also shows us false with this standalone statement. We just have to make sure we correct it by saying 2014 in St. Louis blizzard years and 2018 in St. Louis blizzard years. So that's not quite how we speak, but that's how Python reads it. So it's just something to keep in mind. And it's like, okay, so, but why does this evaluate true? Because this evaluated true. 2014 and 2018 St. Louis blizzard years. Like, you could have pretty nasty logic. Your program doesn't do something right when you do a comparison like this, and you will not see it. So it's just something to keep in mind. And the reason this is evaluating a true, because this is in a this logical operator. Basically, this turns it into some sort of Boolean statement. And the Boolean statement, with just the presence of this, if it's not 0 or none or empty list or empty string, it'll evaluate to true because it exists. It's something other than those things. So this is true because it just exists as a number that's not 0. And then this one's a full statement, which is also evaluating to true. Therefore, the entire statement is true. So it's just something to keep in mind. I like to put that warning out there because you will confuse yourself for a very long time. If you're writing something, you're like, man, I don't know why it's acting this way. And it takes a while to find it because, you just overlook that small thing. So those are the hardest errors to find, the ones that don't give you the exceptions, the nice, they don't look very friendly, those warnings, but they are very friendly. When you see those red warnings, that means your code is telling you something's wrong and you need to fix it. It's worse when it doesn't tell you something's wrong and you don't know where to fix it. So it's just something to keep in mind. And those debugging techniques that you have using print statements, those things will help you debug your code. So any questions on that?
Yeah, when that happened again, I'm sorry, I didn't get that.
What's that?
I didn't get it. I didn't understand it.
Oh, you don't understand right here why this evaluated true?
Yeah.
Um,
It just take the last one. Like Python only read the last one or what?
what's that?
Why? I didn't.
So when you have this here, this and, okay, what you're saying then when you're doing that, you're making this whole thing like a logical operator with two comparison statements in there. When you have just something by itself and you're not actually comparing it, like saying, seeing if it's in a list or anything, we're not really saying anything other than is 2014, not zero, basically. Because zero is false. Zero, like when you are looking at, like if I ran this here, I'll just put a new code window in, just so we can see it. So if I put 0, right? You see here. You see that statement?
Yeah.
0 equals false. They are equivalent in the eyes of Python. (2014) does not equal false. It's false because it is not 0. That's what the presence of this and says, when we put it in a statement like this, we're turning this into a comparison operator. And really what that comparison operator is, really like, does this exist? Is it something other than 0? That's what this is saying. Is this something other than 0? Yes, it is. It is not 0. Therefore, this is a true statement. Because if I said, does 2014 equal true? Well, no. But does 0 equal true? False. Does 0 equal false? True. 0 does equal false, but only 0 equals false. Every other number equals true when it's in this context, when it's in the context of a comparison operator, like, or logical operator statement. So it's just something I'm warning you about. You may get into, if you're writing something because you're comfortable with Python reading like English, it doesn't read like English all the time. And this is one of those times that it does not. And so it's just something to keep in mind when you're writing out, if you're looking for something inside of a list, or you're looking for two comparison operators inside of a logical statement with an and or a negating statement, you want to make sure that you put a complete statement on either side of it. Like this. This is what you want to do, because then you're not comparing 2014 to 0. You're comparing it, or you're not saying, does 2014 exist as itself? No, I'm checking to see if it's in St. Louis Blizzard years. And then I'm checking to see if 2018 is in St. Louis Blizzard years. So
that's only in the comparison, right?
What's that?
I like to think about it very simply. If I'm wrong, you can let me know. For the and operator, if there's logic on one side, there has to be logic on the other side.
If it's true on one side, it has to be true on the other. Yes.
Exactly. So if there's logic on one side, logic has to be on the other side.
Yes.
Unless, if that's not the case, if that's not what you want to use it for, you should use the or, because it'll not do that.
Right, but then the or changes the way your statement behaves.
Correct. Now that's why you have to think about that. That's why I try to make it simple. Try to think of it more simply, because the more words just confuse you.
Right. And so here we have St. Louis 2014 or 2018 St. Blizzard years. Well, that's true because this side evaluates a true. This one does not, but we're using or. It just takes one of them. And it's like, yep.
Exactly. And you don't want it to always be true. So that's why you wanted to use the and in the first place.
Right. So.
Does that help you out?
Yeah, thank you.
You're welcome.
Well, cool. Let's go ahead and take a break. I know you guys started at 6. I really didn't, but we'll keep us on the same break schedule because you guys did a review. And we'll come back at 7. Let's just come back at 7:15 and we will resume the lecture. Pause the recording. All right, welcome back, everybody. We're gonna continue our lecture 3. Like I mentioned before, we went over some, just some operations of Boolean, some comparison operators, some membership checking, and some logical operations with those Booleans to come up with, the kind of the basic way to build a logic tree. The next part we're going to go into are if statements, or the if-else statements, or even more completely, if, else if, or else statements. We have a couple resources here you can go to. Of course, they stay here in the Jupyter Notebook, so you can go to these anytime you want to. Or you can Google these. There's plenty of resources out there to see the code, to see how they work. But this really is kind of the building block of, building our logical operators and building our program to make decisions for us. Just like we talked about with that thermostat in the other lesson, we're going to kind of have the same example down here, but we want to only execute certain lines of code under certain conditions. And these, the statements we learned up here, how to build these, help us drive, which lines of code are going to run, which lines are not going to run. And that's how we get Python to answer yes or no questions. When we think about that programmatic thinking, the computational thinking, thinking like a computer, you're breaking down your problems all the way to yes or no questions. You have to know how to take a problem and break it down to yes or no questions. If you can, you're eventually going to get to that point where you're looking at every step, and it can be just like you take steps throughout the day. You make thousands of decisions every day that are yes or no decisions without really even thinking about them, because you kind of have, the human brain works differently. But you can choose whether you're going to brush your teeth or not. You don't have to brush your teeth, and you'll continue your day, but you're going to have bad breath. You can choose to do it. You can choose to get dressed if you want to or not. Spoiler alert, working from home, sometimes you don't have to get dressed to go to work, so it's nice. So on camera you do, though. So but those if statements, breaking down our problems to those yes or no questions, is important, and that's exactly how we're going to build our programs. The if statement construction, when you write, of course, this if, elif, and else statements, those are reserved words. You can't use those to define other variables. So those show up when you write those. Your IDE will typically turn a different color, and you'll know you're in a if statement. When you do that, you have to kind of put some sort of Boolean statement there. You have to say true or false, right? So in this case, we're defining the temperature here at 12. And we're saying, okay, well, if the temperature is less than 32, we want to print it's literally freezing outside, stay inside with jammies and hot cocoa. And then we have other statements as well that will not hit because right now our temperature is less than 32. And we can watch this work. If we run it, we can see that temperature is 12. If I increase this to 30, it is still literally freezing outside. But once I go above 32, then now it's layer up and stay warm. So I'm seeing that it's going to check here and say, okay, well, is temperature less than 32? False. Move on. Go to the next statement. Is temperature less than 55? Yes. Going to go ahead and print that statement, and that's exactly what it does. Of course, otherwise, it'll evaluate to the else, which is kind of like the catch-all. So any other condition that you can come up with, put that in there. It looks to be a nice day. That's how the logic works. That's how the logic tree works. You can nest these. So if your temperature is less than 32, you can maybe just not print this, but you could say, well, if the temperature is less than 10, it is dangerously cold outside. You stay inside if possible. You can say something like that. So you can add other nested. So you can do if temperature is less than 10, print it's dangerously cold outside. So we can do something like that. We would have to have somehow we would need to stop this from running. In this example, you could break out of it. You could, you know, especially if you're in a loop. But in this case, we could nest and go further if we want. But this is a way you can nest these to do nested logic, and you'll get into practicing that with some of our challenges. So you'll see the logic trees constructed like the one that we have here, but you have to be careful the order you put things in. So here in our example, we have with temperature less than 15. We're saying if temperature is less than 55, print this, right? Well, yeah, layer up, stay warm, but we actually want this one. We would never get there based the way our code is written right now. We can bring a temperature all the way down to -60, and it's still just going to say layer up and stay warm, because this evaluates to true. And if this evaluates to true, and this is an else if or an else, these will not run. The code will just stop right there. So you sometimes when you're thinking about your logic tree and putting something together, you have to think about what's my most restrictive condition. You want to kind of put that first. You know, check for this most restrictive condition first. If that is evaluated true, then something less restrictive, and then finally the catch-all, which catches everything else. You'll have to kind of think about your problem and layer it that way if you have a logic tree like this. So that's just important to think about when you're writing these if, and else statements. The code works. Again, this is another one of the situations where the code works, but it doesn't give you what you think it doesn't give you what you think it would. And if you're not careful, you may not catch it. And all of a sudden, later on, when you've written other parts of your code, you're like, wait a minute, I didn't design this way. Why is it behaving this way? And you'll have to kind of go back and backtrack to find where your problem is. So it's just to make sure you pay attention to that when you're writing some conditions like this, if you're ever set with a problem like this. So you don't have to have if and then else if and else. A lot of times you will, and it's good if you can construct your code this way. That way you know you're only going to get one branch. But sometimes you need to check for multiple conditions. In that case, you can just chain your if statements. And if you do this, though, it's going to evaluate each of them all the way down. It's not, if you have an else if after an if, then this one will only run if this one evaluates the false. But if this one evaluates a true, it will also check this next line as well. If it because it's now not an if else, so else if, so it'll print both. So if temperature is less than 55, layer up, and then my temperature is -60. Oh, if temperature is less than 32, it's also going to print that as well. But an else if works hand in hand with the if statement, and it will stop if it sees that, and it will not continue. Any questions on that?
So when I do something like you did where it's like -60, I guess I'm not seeing the logic here because I'll still get layer up and stay warm regardless.
Right.
If I change it, obviously change it to just if, but how would I get it to print? It is literally freezing outside, stay inside with jammies and hot cocoa. If would it double print? No, it doesn't double print it. I just tried, but
You just got to move it. So you gotta put them in the right order. So this is where, that's what I was talking about. Like this one's in the right order, but you got to be careful when like you're thinking through a problem, right? And you're like, I just want to start coding, right? If you didn't think about it through enough, like you may put things in the wrong order. And I mean, it's okay. I mean, it happens all the time. Like when, I don't sit there and write pseudocode for every problem I have. It's a good practice to do so. It's also good to write your tests before you even write code, but I don't know anyone who actually does. So, but it's just it's just good to think about, like, when you have a problem, when you're checking for your logic, just to kind of just take a minute and be like, well, what's my most restrictive condition? What's the thing that I'm probably not going to hit, but I could hit? Let's check for that first. Let's go ahead and kind of branch my logic there first. And then, okay, what's the next condition that's maybe a little more likely than the other one? Okay, let's do that. Okay, and then, okay, it looks like I wouldn't hit any other condition. These two are the only two I really have to worry about. So else, then you can have an else statement. And sometimes you have to write the code to kind of see what it does before you come up with those, and it happens. But you just want to make sure that you always think about that most restrictive. It's most restrictive if it's less than 32, because under 55 that is not as restrictive as less than 32 when you're considering like normal temperatures, right?
Gotcha.
So that's just kind of what you want to think about when you're writing these if, else if, and else statements. So with those and the comparison operators, now we can move into, change gears a little bit, and we can talk about functions. You've seen functions already. Michael was showing a function during the exercise. These REPLs have, these exercises at the bottom of the lessons, they have functions that you see. Well, now we want to think about writing them. And, understanding these functions, it's really, really important to think about it. And, it's almost comforting to know that you can write code and then not have to think about it anymore. As long as you've written down what it does, and you have a good documentation, and you know what it does, you don't have to worry about thinking of the logic inside of it, unless you find out that something inside of it's wrong, then you have to go in there. But the whole point of it is you want to kind of separate logic out into a nice little chunk, and you keep it there, and then you make other little chunks of software, these little, you can think of little programs or little applications that run. They have one purpose, right? They take some input, they do some stuff, and they give an output. You're only concerned with the output. That's really what you want to write your code to. Okay, I want to consider this code, write it, give me an output. Okay, cool, I can put it over here. And now I know if I go and put my input into that function, it does its thing, and output comes what I need. That's exactly what you want to do. And that's, if you think about an application you're using online, whether it be Microsoft Word or any other program, those have code, and everything that you do on there has some sort of function. Just like on a website, when you're mousing over things, this is a Jupyter notebook, but when you mouse over it, there's a function causing this highlight thing as my mouse moves. There's something tracking my mouse. Some sort of function is keeping track of that and giving an output to have it do something. When I click, that click is sending something somewhere to return whatever is in this menu. That's in the operating system. It's grabbing the operating system doing that. So every small thing you do, there's functions behind the scenes that someone has written, and it's being used. But you don't see it because you see the entire machine. This entire VS Code is thousands and thousands of functions put together into their code base, and they all work seamlessly together. Sometimes you find bugs, right? But that's exactly what it is. And so when you're writing functions, typically you're not, unless you get into application development, or you get to a company where you're writing stuff like this. When you become a developer, an application developer, typically you're writing stuff that's going to be getting user information and querying a database or something like that. And so that's when we think about functions, just you are going to be establishing how the computer takes the input and comes to the output, and you're putting that together, and you're putting a nice little package, and then it's just going to sit there and do the thing you want it to do, hopefully. And that's so. Let's get into kind of the construction of how functions work. In this function, I have a definition. So I'm defining the function. You've seen this on those replets. You have your, this def keyword here. It highlights blue. It looks different, right? And then I have a name for a function. Hopefully it's a descriptive name because it's a variable name, but it's for a function. So your function name, you want it to be descriptive of what it does. Typically, that's the guidance in Python. Sometimes you can't. A lot of times people still make them pretty cryptic, but that's also what doc strings are for. And then you have this open and closed parentheses. So you have to have this even if there's nothing in there. In this case, I have two things in there. And then I have a colon. So that colon kind of defines the main part of the function. And then everything else is indented. So Python, you always indent everything. Everything indented out of the function is the logic, the how. You're writing the how the function works at that point. So this right here, of course, the magic to writing this, it takes some practice, but there is a moment if you're new to development, there is a moment where it just clicks all of a sudden. You're like, oh yeah, like I get this now. If you notice, I have like an if statement here. I'm doing something with it, and then I'm returning something. So that's the key to a function. I'm taking an input. These are the two input pieces. The logic is doing something with those pieces of information, and then it's returning something. Okay. Now the highlighting is weird here because this is in Markdown, but if I go down here, you can see that now I can kind of see what is being highlighted here. If you notice, I'm using input data here, and I'm using target name here, and then I'm doing some logic. Okay. And so just keep in mind, you're defining a function first. You always define a function first before you use it, unless you're using a method or a function that already exists in Python. So, and if you look, this looks a lot like the methods you find in Python that native. They're green, they're just different color, but I'm calling the function here. So just keep that in mind. Now, if you take a look at this function here, I have two inputs here, and I have two inputs here, but then I have only one input here. You have to make sure when you define a function, you kind of have to remember how many pieces of input data or parameters or arguments is another name for those terms. How many of those you have. You have to have those. If you don't, then you will get an error. And so in this case, I can run this and I get an error because it says it's missing one required positional argument. Input data actually tells me you're missing input data. I don't see it. I don't know where it is. And so I need to put that in there. So let's go ahead and copy this. I will copy that. And I will put that here. Okay, and I will copy that. And I will put that there. And cool. One thing also to keep in mind before we actually run this, where it'll actually work, when Python evaluates the script, it's, Python, just like any language, will evaluate things from top down. So it's going to start here. And it's going to say, okay, I have a function here. Cool, neat. Okay, I've read that. Now I'm going to continue. Python doesn't do anything with it yet because it hasn't been called. And then it's going to get to the line 9. It's be like, okay, long string of data. Okay, cool. It's a long string. It has things in it. Neat. And then it's going to say, oh, find name. I know that. That's a function that was already defined. Cool. They're calling it. Okay. And now it's giving me a parameter that's target name. And then this parameter is now input data. And then it goes back up here to line 3 and starts running the program. And so when you watch it, you'll see it in Python Tutor. You can put the stuff in here and kind of watch Python work through. You'll see this little arrow move through the code. Does anybody want to see that?
I do. Yeah.
Yes, sir.
Cool. There we go. Awesome. So there we have the function. we have our comments, we have everything else. It looks a little different here, right? So if you look, like, my parameters don't look all fancy like they do in the IDE. So this is just a different styling. They don't have as, robust the styling here, but just remember it's all still going to work the same way. It just does not look the same. Okay, so it looks like I have 10 steps of this program. And if you watch, I'm going to run through this. It's going to see, okay, there's a function. Cool, moving on. It's going to go right down to line 9. So it's running top down. And then it's going to say, okay, cool. There's my long string of data, and there's the stuff in it. So it now defines this variable as long string of data. And then it's, oh, now I'm going to call. So it's going to go back up and say, okay, now I need to go into this find name function. So when you see this global frame, that means the entire program. Now I'm in this other frame called find name. That's called scope. We'll talk about scope here in just a minute. Okay, and it's going to go in here and it's going to say, okay, cool. I have a target name, and that's Aaron Wood, and I have input data equals Jim Wallace, equals the same thing as this, but it has a different name now because I renamed it inside the function. Inside the function, long string of data becomes input data. In the function, Aaron Wood becomes target name. So inside the function, this is where we don't care what's happening inside the function from outside. I don't care what's happening in this respect here, but when I'm in here, now they're in their own little world now, and the function's going to do its thing, do its magic inside its own little box, and it's going to. All I care about what comes out. Okay, so I'm going to go through, and now I'm making a new variable called false. So that's this is the line that just executed. This is the line that's about to execute, and then run through it, and it's going to say, okay. Name location is the result of the find method on my input data, so that list, and it's trying to find target name being Aaron Wood. And it says, oh, yep, that is now equal to index 108. And then I'm moving on, and I'm saying, okay, well, if name location is not equal to -1, I know that Aaron Wood is on the list or in the list because it didn't come, the find method did not come back with -1, which means it wasn't found. So I run that. I'm going to change present to true. So now present is true here. And then I'm going to return present. So I put in these two things. The magic happens inside. I'm checking to see if Aaron Wood is in the class. He is. The return value is true. These are the inputs. The magic happens. The return value is true. If I change this, if I change my name to Billy Madison, visualize the execution. It's going to go through it all over again, defines the function, gets the global frame, gets the long string of data. Now I'm in my function scope. I'm going through. Present is false because I haven't done anything yet. Now here's where the real comparison happens. Name location is equal to -1 because Billy Madison is not here. He's not present. Therefore, I'm going to skip because this evaluated to false. This if statement, that means this logic did not run. And so Python tutor skipped it over because I don't want to change present to anything. I don't want to change it to true because it wasn't found. And now return value is false. That is a basic function. And that's what it does.
I have a question.
Okay, looks like Hamilton just, so line 4 name location. Okay, so here, so for line 4 name location, okay. You're saying, can we use two methods such as using lower and then find? Yes, you can. In fact, that would probably be, better because of, human error, making mistakes, right? So you can't trust users. If I wanted to make sure that everything was, if I want to make sure everything was in lowercase, I could do that. I could say, well, find target name dot lower. So now I'm Now I'm taking my target name and I'm just getting rid of all the capital letters. I'm making it all lowercase. And then here, input data. Input data is also a long string, so I should be able to do dot lower dot find. And then I can put in, I know I'm in there. If I put that right there, hopefully this evaluates it true. Hopefully I didn't make a mistake. Going through, it looks like it will result to true. And you can actually see it here. It still found it because it ran the dot, it ran lower. It still found me at 108. It's true. It returns back. Now you don't have to, you can do any, it would become case insensitive at that point and it will still work.
I have question, please.
Yeah.
Yeah, before I got everything, okay, I understood it. But only the, you know, line 5, if name, okay, location, not equal -1. Why -1? -1 out of the range of the string.
So if you look at the dot find method, so right here, right? So this dot find method, if you
Yeah.
remember in the strings,
Yeah, I remember. Yeah.
okay, it returns a -1 if not found.
Oh, okay.
So I'm saying if the result of this find method is not -1, I found something, and that's where you can use that negating. That's the negating method, that not. Okay, I'm just saying a different way. I'm saying does not equal. This is another way in Python to say not. You know, it's negating something. So if name location does not equal -1, I found something and I know my student is present in the list.
Okay, and why we start with the variable present equal false? Why we don't just write the function and present equal true if it's not, you know? Why?
I mean, I could, but the problem is you have to define it somewhere because I'm returning present, right? So
Yeah.
so I need to have a default, some sort of default for present. Okay. I could do it other ways. I could say, I don't have to define anything up here. I can say it's false up here or nothing
Yeah.
there. And then I can say else present equals false.
Yeah, false. So it's gonna be the same.
It'll be the same. That's the same logic. All I'm doing is I'm saying, hey, I'm false by default. If I find somebody, it's true, and I have to. I'm still returning present.
Okay, I got it. Okay, thank you.
Yep. Another way you can do things is you can just say, you can do it like that.
Yeah.
That's a common mistake in my name. People always make my name plural. But so yeah, you can do that too. I don't really care for this practice. And there's opinion articles out the wazoo for for this. I really don't like to write logic like this. I like to have a variable and then I return the variable after changing it. So I have one return statement. I don't really care to see multiple return statements, but it doesn't really bother me that much. Some people are very passionate about not having multiple return statements in the branch logic. I can see the benefits either way, but I do prefer to make a variable and then.
Yeah, but that's my question. Why you prefer to put variable by default is false, okay, unless the condition statement can find it or become true. Why you prefer that?
So instead, so why did I do this instead? Like, why did I do this
Yeah.
right here?
Yeah.
Well, because I mean, if you think about it, like, I want to know what students are here, right? So in this case, like, I mean, I could write it the other way. I could say present equals true if name location equals -1, present equals false. I could do that. I could write it the other way. This is just the way I chose to write it. And that's the way I've kind of fallen to thinking. When I'm writing a program, I like to have, something already set. And I want to change it. I want to explicitly change it based on a condition, and I know I'm going to change it. With React, I'm getting a bit into more advanced stuff with Platoon, but a lot of times you'll be setting state in a web application, and a state means like it's some sort of like, there's an attribute of the site, if you will. You have to instantiate with something, and typically you'll do it like with false, and then you can set it to anything really, but typically you'll set something to false and then only mark it true if you need to. Because typically if something is, marked as false, it's not going to run. It's not going to return something. It's not going to do so. False is a negated kind of state, if you will. So, did you have your hand up, Michael?
Yeah, I was just gonna ask you, like, this function that you had at the very beginning, the way it was at the very beginning. I think it looks like this, yeah. If this is an example of clean code that's dry, what do you see like beginning students do differently than, let's say, this ideal code snippet? I was wondering, like, that present equals false. Might some students like lead with that and make it the very first line, and it would be a global variable rather than a local variable to the function? Is that something that beginners tend to do? Do beginners tend to put present equals true? Do they tend to think that way? And as they become more experienced, they write code like you have here?
Well, I mean, I think beginners don't even really, they don't divide their logic into functions. So they'll write code that operates top down and try not to use functions at all. So they'll be defining things in the beginning and then changing them. They'll have to go back and think about, okay, I need to change this. Okay, I need to change that. And they'll write just a script that does stuff. Understanding how functions work help you break up code into reusable bits so you can reuse them. You can use them later. For example, now I don't have to write have to write something that, I don't have to write this logic over and over again to check each name. Let's say if I wanted to write a loop and go over these, right? I don't have to write this logic over and over again. I can just write a loop and say find name on this one. So for item in list, if this was a list of names for item in list, find name at the first item. Then basically it's going to redefine the item and then just send it up to the function and reuse it. I can write very small amount of code to evaluate these if I wanted to. But beginners sometimes forget that, or they're not very comfortable with functions, and that's what we're trying to just make sure you understand here. And that's what you're exposed to in the very beginning. When you start the coding challenges, you see functions. And so I think it's important to understand how they work. And we are going to get into like a little more in depth with functions near the end. We're going to build something that actually requires quite a few functions. And I think that's where hopefully a lot of it will click for everybody. So
Chad was saying early on that, like maybe in an interview, you might be presented with this function and asked to rewrite it without using a function. And if we tend to start with functions and get comfortable with functions, and maybe we don't learn how to do it without the functions. That's all we know, functions.
Yeah, I mean, I don't think that's all you're gonna know. I think you could still come up with a way to evaluate this without a function. You don't have to even write this as a function. You could literally write under long string of data. You can just say, Aaron Wood, or maybe make Aaron Wood a variable and then say variable dot find, you know, or input data or long string of data dot find Aaron Wood. And then you can define that as a variable. You can basically take this and pull it out of the function, not even call the function. You could do that.
Right. Okay.
But the beauty of this right here is right here. Now I can just change the name right here. And I don't have to rewrite the logic of doing that. I just need to do this right here. And I can then print this. I'm going to print both of these because the Jupyter Notebook will only give you output the last command if you don't include a print. But if you put a print, then you're explicitly saying go to the output. And, you know, but here, now I can run that. And I can repeat this with all the other names or put that into a loop. And then I don't have to worry about writing a bunch of code. But that's the beauty of functions right there.
And that's what makes it dry.
That's what makes it dry.
Okay, thank you.
Okay, and I have a question.
Yeah.
Can you make it in for loop? Can you write it down or?
I will at the end of lecture.
Okay, that's good. Okay, thank you.
Yeah. And what I haven't really, I mean, I did talk about return statements a bit, but you know, you don't have to return anything. A return statement is completely optional for a function. A lot of times you want something back so you can, you know, that's the whole point of having magic box. But if you know your function is going to do something and set some setting elsewhere, and you're comfortable with that, that's fine too. You don't have to have a return statement. It can return nothing. You can just have it do something and then return none. That happens too. So you don't have to have a return statement with a function, but typically you'll see them have them. So in here we have a multiply function, and we're defining a result. So we're saying, hey, result equals my variable result equals the result of multiply 4, 3, right? And then when I do this, I can actually define the output of a function to a variable and then print it. And so here I'm doing that. And then when you get to the multiply function, 4 becomes A, 3 becomes B, and then I'm just returning that multiplied. So that's another use for functions. You can make it equal to variables. You don't have to do that. You can still call a function this way, but this is pretty common way to see functions written, especially longer code. Any questions on that? Okay. When I was showing that function in Python Tutor, I was talking about scope, and this is a section about that. The function is like its own little world. So it's completely isolated from the outside world, outside of the input. So the doorway into a function is with the inputs. When you define it, you're kind of welling off this area from the rest of the Python program. Python, you know, the rest of your program doesn't care what happens inside your function. All it is concerned with the part that comes out. Just like when if you don't have an electric vehicle, if you still have a gas vehicle like me, when you go to the gas station, you know, you care about how much money you're putting into the gas pump, and you care about what comes out of the gas pump, but you don't think about how the gas gets there. I mean, you can see the truck come in and put the gas below ground, but you don't care. You just want to use the gas pump, put your money in, and get gas out. You don't care how it happens, how that special valve works, or when it turns off, and you try and use it again and again and again and top off your tank, right? You don't care about that. You just care about getting gas in your car. That's exactly how functions work, and that's exactly how function scope works. In this function here, this one's a little crazy. It's a little bigger, you know, 29 lines long for everything. this function is kind of a useless function, if you will. But this illustrates some things about function scope that I wanted you to see. And so let's take a look at this function. Let's start at the top, and it looks like we're defining numbers, right? We're saying, okay, my number equals 5. Okay, my other number equals 6. And then my operation equals this minus sign. It's a string with a dash. Okay. And then I'm going to say unused variable is equal to 1,000. Okay, that's cool. I have an unused variable. And then I move to defining my function, and I'm saying, okay, I have a number processor here. Spoiler, it's like a calculator. And I'm okay, I take some arguments in here, and I have a num1, a num2, and operation. And inside there, I'm doing some stuff. So I'll get back to that in a minute. And then I'm gonna say, okay, this is a result of number processor on my number, which is 5, my operation, which is 6, and my other number. Okay. And then I'm printing out. Okay, so here I'm actually calling the method or the function here at this point. So I'm calling number processor, and I'm saying, okay, 5 is going to be num1, my other number is going to be num2, and then my operation is going to be whatever that is. Okay, and then I'm putting a new line statement in there. So I'm going to go in here. I'm going to start going into number processor, and I can show this in Python Tutor, but right now I'm just going to keep going. So now it looks like inside the function I'm redefining unused variable to 999. Okay, and I'm going to do a print statement and say unused variable. So I'm going to print unused variable inside the function as unused variable. I'm not using it, but I'm using it. And then it looks like I'm taking number 1 and I'm redefining it to 9. And I'm taking number 2 and redefining it to 25. And then I'm doing some logic here. And I'm taking operation, which is my operation. It's being renamed to operation inside the function. I'm saying if operation equal to plus or minus. I'm going to make result equal something. It looks like I'm doing the mathematical operation that's ties to the string representation of that, and then returning it. Okay, I see what the function's doing. But if you look, I'm redefining my number, which is num1, to 9, which means this is basically silly. It's redefining something that's not going to work the right way. So I'm going to go ahead and run it. And I say, this is the result of number processor on 5 minus 6. Okay. And then unused variable inside the function is 999. And then I'm getting minus 16. So that's the result of 5 minus 6 is minus 16. Well, that's not true. That's 9 minus 25. But then I'm actually printing my number after the function runs, and it's 5 still. And my other number is still 6. And unused variable after the function is run, even though I redefined it inside the function, is still 1,000. That's the illustration of function scope. This is a stupid function because it doesn't work. It redefines a variable, but it illustrates the scope issue, which I can change things inside the function, but it's not going to affect anything outside. So that's kind of just illustrate how that function scope works. I don't care what happens in there. I care about the result. Well, I really care about this result because it doesn't match what I put in. But if I just commented these out here, I'll comment all 3 of these actually, because I really don't care to see that. Let's try that again. So I work on Windows during the day, and I work on a Mac at night. And so I hit Control a lot when with Macs, it's Command. So let's play this again. Okay, now that works, right? So this is the result of number processor on 5 minus 6, -1. So I got rid of the redefining, and then it kind of shows, unused variable. I'm not redefining it there, but I can also redefine this without printing it and run that. And still, it doesn't change to 999. That stays inside the function. So And I just tried to change it just the same name, unused variable. I tried to refine it here, but it didn't last. It didn't, because I only do that inside the scope of the function. Any questions on function scope and how that works? Cool. Let's look at another example here. So anything defined inside of a function is only accessible inside. And so if you think about it, like I didn't just change this. I didn't decrement it by 1. I redefined it. I redefined unused variable as 999, but it didn't take. This is the same thing. If I'm defining something new inside of a function, I can call the print method on whatever I called inside the function. Right? So here, I can even kind of make this a little more clear. Printed inside function. Like that. And then I can print outside. This raises an error, but I can run that and say printed inside function 10, x equals 10. I call my function, get the print statement. I try and print x here. Python has no idea what x means outside here. Has no idea. It knows what it means inside of a function, but not outside of the function. So that raised an error. Let's go back to Python tutor and do that real quick. It didn't even let me do anything. So I ran that and went straight to let me edit this code. Yeah, that's good. Yeah, it's not even let me do it. It's just immediately saying it's done running. Oh, there we go. All right, cool. So here I have my function. That's weird. It never even does that. That's weird. It didn't even let me go to step 1. It just went to step 7 and stayed there, which is really weird. So then I have, okay, I defined my function. I have a function. I'm calling my function. Now I'm going into my function. I'm in my function scope. This is global frame. This is inside my function. X equals 10. Okay, I printed it. Now I'm going to print X. And then Python's like, I have no idea what that means. So. Let's see, we only have just a little bit left to go. I think what I'll do is just keep going and then we can take a break at the end. So when I debug or when I'm looking for things, as my code's running inside, especially inside a function, I'm building a function. I want to kind of track what Python's doing. I will put print statements in there to kind of see what's going on. I use them all the time. I probably shouldn't, but that's kind of my go-to for debugging, for quick debugging anyway. There are very nice tools in Visual Studio Code and elsewhere that you can put like breakpoints, and then kind of it'll give you a nice little list of the variables you have and what's happened with them. I just haven't taken the time to learn it, so I still just use print statements in my code actually quite a bit. And one thing I saw Michael doing with that last exercise, it's great, but when you start throwing out a bunch of print statements and you have no descriptive text before it, you can confuse yourself. So I advise when you're writing, like if you're trying to print statements, like you can say, like here in this example, line 3, intermediate result, and then you put your product like that you want. That way kind of where you printed. So it's just a way to identify. Sometimes if I have like in my primary job, I'll have a program that has like thousands of output as it's going through reading files and giving me results. I will put like something like this that stands out on the screen so I can see where it actually printed out, because I may have like 100 or so printouts or something else, and I want to be able to see that stand out. So I'll do that sometimes too, just to see it. Not the best practice, but I mean, it's okay for debugging. Print statements are fine for debugging, especially simple problems like these. It's a quick way to do it. So in this case here, I have a complex calculation. So let's take a look at what it's doing. I'm defining a function, and then I'm calling a function down here. So just like we had before, we define a function, put our name, we put our parameters, the colon, everything indented is inside the function. I'm returning a result. So I have a return statement. Looks like I have an if and else statement. So I have some logic tree going on. And then I'm running this complex calculation on -2 and 30. Okay, so I'm going to run it and then see what we get back. So I'm saying, okay, so -2 and 30 goes in, and then I have my product, and it's -2 times 30. Then I'm printing my intermediate result, which is -60. And then, okay, cool. So like the whole point of me doing this, just kind of make sure my first step works. So that's really what I'm doing. Intermediate result, and then my program runs more, and I'm saying, okay, looks like I'm doing some weird method here that we haven't learned. That's the absolute value. So I'm just taking whatever number it is and just making it positive. So if it, in this case, my intermediate result is -60, with this, it turns into 60. I could also see that by printing right here. So print, I can say f string. So we're using f strings. Remember, we learned those yesterday.
Yeah.
F strings are the formatted strings. This is my result after the other step or something like that, right? And I can put a colon in my curly braces, and then we can call product again here. Okay, so now I can see on line 5. So after this one thing, I want to check to see if these are actually doing what I want it to do. Typically, you're not going to be doing this for something small like this, but for something maybe a little bigger, or maybe something after another function call. So I can call, I mean, I'm calling a method right here. I'm calling another function inside my function. So, but this one's not written by me. This one takes the input and it gives you an output. So I'm just going to check it. Okay, result after the other step. Oh, it got rid of the minus sign, made it 60, right? And then if product is less than 55, doesn't meet threshold, otherwise it meets threshold and return result. So that's what's happening. So you can use those print statements in there. I recommend you kind of put descriptive string before it, make an F string, put your variable name, or just, you could have a comma or something. So that's just something you can do. So this is a way to kind of do a bit of debugging or like status checking in your function. If your function's a little more verbose, sometimes functions get pretty big. That's another thing about functions. If you find your function is, getting to be very big where you're having to scroll inside your function, you may want to think about breaking your function to smaller functions. And it goes back to the problem solving methods and breaking your problem down. Is your function doing a bit too much? It may be, or it could be you're just multi-tiering. You're doing a function, then you're using that to call other smaller functions. That's exactly what you're going to do. There's actually extensions where you can do that, where you can right click on you can like highlight a piece of code, and then you can like right click and you can extract to a function. There's VS Code extension that do that, and it'll just define new function with all the stuff you highlighted, and then replace what you highlighted with a function call, and it will actually put your parameters in there and everything. Okay, but for the purpose of this class, let's try and write them first so we can understand how they work. That's the most important piece of this. So let's go ahead. We have an exercise here. So I figure we can just spend some time trying an exercise on our own for maybe like 10 minutes. Try and write our own function that determines what letter grade prints out when called with numeric grade as a parameter. So in this case, we have letter grade, and then we're making a function called letter grade, and we're giving it a parameter of a number, and then we want to return the right letter grade. And then we just want to make sure we define the function first, then call it. So let's go ahead on our own. If you have a Jupyter notebook, you can also watch along. when we go over it. Let's spend a few minutes trying to do that, and then we'll also just take a break. So let's just come back at like 8:25, and then we can then go over the conclusion and the assignments, and answer any questions, go over any exercises, and that kind of stuff. So let's go ahead and do that. I'll pause the recording. All right, welcome back from the break. I hope everyone had a chance to try out this little, quick exercise. It's a function that's going to check to see, what we have for a grade. And Michael submitted one in Python Tutor, which is kind of cool. Right here. And I think what I'll do is I'll just copy it over to Jupyter Notebook. We could run it here if this ad will go away.
I'm a former high school math teacher, so this is something that I was quite comfortable doing.
What's that? You are uncomfortable doing, or you're comfortable?
No, I said I'm a former high school math teacher, so this is something that I used to do all the time, as far as just like in a syllabus or something in the grade book to do this kind of thing. Not using Python, of course, but just the English language.
Okay, so here we have print grade. Okay, and we're saying score equals 70. Okay, let's break this up here so we can kind of see a little better. Okay, so you're defining your function here, and you're not returning anything. So you don't have to return anything at all, right? So in this case, we're not. Now, a function does not have to return anything. And then you are just printing out the result of this. And you're trying a bunch of different grades, right? So and you're saying in your logic in your print grade, you're saying if score is greater than or equal to 90, print A. Else, elif score greater than or equal to 80, do that. And yep, so you did it in the right order, where you kind of go with your most restrictive, right? So going from 90 up, you want to start with that first and kind of work your way down. And then when you get to the D's and the F's, then you're working your way from 90 on down. Okay, so if I ran this here, I get A none, B none, C none, D none, F none, C none. What are those nuns? What are those?
Those are implicit returns, given that I didn't return a value.
Yep.
Yeah, those are from the print statements. If you turned it to return, it wouldn't do that.
Right.
Yep. So if
when you don't return something, then Python returns none.
correct.
No, it's annoying.
So I wanted to explain something. Originally on line, is it line 1 up above? Yeah, on line 2, when I defined the function, for my parameter, I just had score. But then when I ran line 20 and I did not include an argument, it returned an error. So I said, well, let me put a default score of just 70.
Right.
So in case there's no argument, at least it will, use 70 for the value of score.
Right, and so that could be something you can do. So that's a good point for functions. You can have if there's also ways to do if you don't know how many arguments you're gonna get, you can use star args. But in this case, if you're gonna get a score, but you don't know if it's gonna be empty or not, or non-existent, you can default it to a value. In this case, he's defaulting it to 70. I probably would default it to something
None?
else.
Well, could I use none?
You can use none, or you can use a string. You can use you can use anything really, but you can put none for now, right? So score equals none if you don't find one. And then you can say, elif score, less than 60. Print F, and then else print score not found, or something like that. You can do something like that too. And then if you run that, let me see here. It should be 70. Oh, it's trying to do a comparison now. Now you have another error because it's trying to compare that none type to an integer. So you may want to make this actually first then. So make that your most restrictive then. So you can say if score equals none.
Could you say if score is not a number or?
Yeah, I mean, but you know it's going to default to none if it's not found. You could do that,
Okay.
or you can say if score, if score is not a number, or you can do all sorts of comparisons, and you're free to do whatever you want, really.
Yeah.
In this case would cover anything that is defaulted, because it's going to be none if it's not there. Then you can print
Would,
found
and would you change line 5 to an elif or just leave it as is?
LF, yeah.
Okay.
Yep, and then you actually go back to else here, so else print. I'll fix that here in a minute. Tab. I think that would work. See if that will give me an error. Yeah, it doesn't give me an error.
Yeah, I commented out line 24 because, you know, it was returning an error. And I just thought, well, what if somebody puts, you know, a character, a string in there, you know, and so.
Well, see now, yeah, you still have to have something there because it's not like not provided, it's provided as a C. And so what else could you do? How else could you solve that?
Could you say not an integer or?
Yeah, or you could do something like, let's say for example, if someone's writing here, but they've already done the calculation themselves, but they actually put it in there. Like you can then just have like letter grades equals a list, and you can do A, B, C, D, F. And then you can say if
Grade in letter grades?
in letter grades print score.
Wouldn't this be a good use case for or? For none or letters?
What's that?
Wouldn't this be a good use case for the or statement for none in letters?
Oh, I see what you're saying. So like so if like
Yeah, so you can put it there or as the first statement. Yeah.
so here I want to print the score if it matches, and then yeah, otherwise I want to return some sort of descriptive error, like you must have put something wrong, or there's
Exactly.
yeah. And then I don't want to put an or statement here because I want to check to see if it's in there because I want to print the score. So this would solve that problem. They printed the C. So solve that problem. But let's say they put a G or something, or the typo, like you have to handle that too. We're really getting into like, how do you solve these like user input issues, right? So how do you these edge cases, like now we're thinking of edge cases at this point, and we're like, how do we solve that? How do
Well, it's a real problem on front end or scripting.
what's that?
It's a real problem on the front end or scripting.
Yeah, like with using user input is a real problem. Got a hand up here. How do you say your name?
Murad.
Murak?
Murad is Egyptian name. Murad.
Okay.
Okay. Egyptian Turkish name. Yeah, Turkey and Egyptian. I'm half Turkey, half Egyptian. Yeah, originally. The parameter score, okay, equal none. Why we didn't put just the parameter score?
So what Michael was doing was he was trying to come the way to handle basically any kind of input into the function. So let's say you just call print grade, but you don't provide a score. Well,
Yeah, no, we will put score, but without none. It's gonna work, right?
that will not work for this case. Because when you call it, it says it has to have a parameter. When you don't provide a parameter, it'll give you an error because it requires an argument. So when you put this equal,
Okay, I got it. He's trying to make it perfect. Okay, I got it. Thank you.
yeah. So what that does, just if nothing's provided, it's going to inject one and not give you an error, basically.
Thank you, Michael. Yeah, thank you, Michael. That's a good one.
You're welcome.
So does anybody else have a solution or have a function they wrote? And you can either just put it into the chat or you can make a link like Michael did.
I'm just watching along, but is it possible to put it where if you put, I don't know, a word and then you put an if statement in the very top, having like, if you put an input saying, you put letters, and then it would say, input error, or like, hey, put valid numbers or something.
Like,
They
So-
just saying if you don't put a number, if you put like, I don't know, the word 80 versus just 80, the 80, and then it would just say input numbers, so you could put an input number and then it actually gives you the grade, just so it bypasses that problem, if that makes sense.
so you're saying, so here, let's do it right here actually after this one. So it's if score, here's a good one. If score dot is alpha, print invalid entry or something like that. Because basically that would cover anything that's only letters, but because I'm checking these first, it won't be just these, because that would get caught. And I do LF like that. And then if I have, let's say here, instead of a C, I have 80 like that. Let's see here. Int object has no, okay, so it's supposed to be a oh, it's checking the first one here. So I can't do that because it's checking this one. So let's just comment these out for now. We would have to figure out another way to solve that. But if we try it here, invalid entry.
Aaron, one of the things I love about Python is that whole range thing where you can use the range. Would it be possible to say if score not in range 0 to 100 or something along those lines? Just return. If we don't have a score between 0 and 90, just return.
I think so. Yeah, because when you are using the range method, again, that's going into the future a bit, into loops. But when you're using the range method, you're creating an iterable. And so then you can basically have Python create an iterable on the fly to check to see if something's in that iterable. So you could do that. So let me share Victoria's answer real quick, and then we'll get back to that. Actually, that's a good question. Okay, so also one thing, yes. So Victoria can't get anything to print. And that when you have problems like this in class, especially, let's go ahead and share them so we can figure out what's going on. Okay, so this is Victoria's code, and Victoria said defining print grade, and then also defining a default variable with their score, but score right now is fed in. And you are okay, so you kind of pulled some of the stuff I was doing, and then if print grade and letter grade print score, okay, boom, boom. And you're saying you can't get anything to print right now as it is, right?
Yes.
Okay, so remember when we have functions, let's go back up to the top here, right here. No, right here. When we have functions, we have to define them, and then we have to call them. So if you go back down to yours, you're not calling it. So you're defining it. So Python will say, cool, that's a cool function. But it's not going to do anything with that function until you actually call it. And so you have to actually say print grade, and then put a score. So 85. And there's your B. So just remember, you have to call it at the bottom. Python will evaluate the function, but if you don't call it, then it doesn't do anything.
Okay, that makes sense.
Cool. Yeah, that's part of the thing of the function. So you're just kind of constructing it, and then you'll use it. You'll use the function call somewhere else, sometimes on another file. If you have these utility functions you've made, and then you want to access them later, you can do that. That's exactly what it's for. You define them somewhere, you put them away in a little box, you know they exist, and all you care about is the output, and then you call it for the output later. So back to the range. So you're saying let's comment. So let's start from scratch here, so we can kind of get I'll just comment this out as well. We'll just put some new fresh code here. So you're saying if score not in range, I put double space, range 0, comma, let's do 101. Print impossible score, which we know a score over 100 is not impossible. That happens all the time. So let's just make it 110 or 111, so we can include 110 in case you get 10 points extra credit. So impossible score. And then here we say we don't need to print the function call because we're printing without returning. And then we can try a couple. So we can do 80 and then do 112. And then for the really special students, -5. And we actually want 0, right? Because we want to include 0, because 0 can be a score, but you can't get a minus score. But run that. Impossible score. And then, of course, we didn't see that with the other one because it is a possible score, so we didn't actually print. So looks like that one.
Yeah.
Yep. Range, what it does is it makes an interval. It's a way we loop over things, and we'll go over that. But yeah, the range method is really cool.
But what I was wondering is if you, on line 5, you just put the keyword return and you're telling it, hey, you know what? If the score is not in this range, then just return. And then if the score is within the range, then proceed to line 6 and 7 and 8.
Correct. Yeah, you can do that. You can have return statements that will stop a logic tree if you
Right.
want to stop there. Again, those are okay, and I've used them before. I tend to like to make variables and then return the variable at the end. But yeah, I mean, it's whatever your preference is, really. Yes, you're on.
Yeah, I noticed when you name the function here in Python, you use the camel case, like.
Yeah, I didn't. I was going to mention that, like some of the functions we've seen. Just remember, with Python, you typically want to have the snake case, which is like that. Yeah.
But the function you can use it. You can use camel case.
Yeah, you can do it. I mean, it's a syntax that's prescribed by what's called PEP 8. It's a style guide, just like you have the college paper writing guide, the MLA, I think, and APA formatting. the PEP is that same kind of formatting like guideline for Python. And it covers all the syntax with Python, what should be there, but there's nothing in the code base that will restrict you from doing something different. So
I can also when I create variable, I use the camel case in Python. It will not give me error.
it won't give you an error, but another Python developer is going to be like,
Yeah,
why
we
are they using camel case? So
no, because I saw you use the camel case here now, so I thought in the function when we create function and we name it,
oh,
we have to use the camel case, not the
oh, I copied this over from what Michael gave, so he had it there. I didn't write it, but yeah. So that's what, yeah. You can still use it, but again, yeah, you should use snake case if you're using Python. So
And I'm transitioning from JavaScript to Python, so that's kind of
yeah, me too. That's very confusing.
yeah.
Yeah.
But one thing that I like about like this particular name is that we talked about sometimes the difficulty of coming up with variable names. That it's recommended that you use a verb and then a noun. So you're asking yourself, well, what does this function do? It prints a grade. So it's a good name to say print verb,
Yeah.
noun, grade.
yep. Martin, you have a question?
All right, sorry about that. Yeah, so just kind of a basic question. What's a good indicator to use an if or an if else statement in writing a function? Because like for the exercise, it just kind of didn't like clarify like if this or that. What's a good indicator when you have a question to write your function as an if else statement?
I mean, that's just, you're going to have to kind of step through the line. That's the programmatic thinking that you're going to have exercise, right?
Okay.
And so this one here, I mean, it's for letter grade. There's different ways you can measure these letter grades, right? Just like with Michael said, can you use a range? Yeah, you can. In fact, you can do the sub ranges of, 70 to 79 or 70 to 80, then, 81 to or 80 to 89 and 90 to 90, 90 to 100. Like you could do that. You just want to make sure when you think about how you're going to structure your code, like you want to think about, okay, if I'm going to print this grade, right, what's my most restrictive condition? I want to start and check for that first, and then start checking the progressively least restrictive conditions. If you notice, what is an F? An F is anything less than 60, right? All the way down to 0, that's an F. But then you have anything that's 60 down to or 69 down to 60 is a D, and so on and so forth, all the way up to A. So the A is going to be your most restrictive because that goes to the top of the score, which is 100 or 110, if you will, and you work your way down. You're just logically placing it in order for Python to check. If you have these any way out of order, if I move this 70 up here, if I moved it up, then a lot of people are going to be getting C's.
Right.
So, and this will never be hit. And there's some ways like you can make your development environment like flag code that will never be hit. Like some will turn this like gray or a muted color, and if you mouse over it, it'll say unreachable code. And because it'll already see that you're checking a condition that can never be reached below here. And so there's IDEs that do that. So that also will help. If you find that, you can use that too, but I really recommend just trying to see it on your own initially during these exercises. So
thank you.
Yep. Well, cool. So that's really it. Really it with the lesson. We talked about conditional statements and using those to construct if and else statements. And then we moved into writing functions and calling functions and learning how to put stuff into functions. Just remembering that those functions are the building blocks of Python code when you're writing it. And what you're doing is you're taking this, you can do anything with Python and manipulate data any ways, but you want to package up those functions into blocks and use those blocks to kind of build your code base. until you have a full functioning program. That's what you want to get to. And then this right now, though, what we're learning is just how to build those. So, yeah, we do have a couple things here, a couple assignments on Replit. We can talk about those next time on Monday. But yeah, we have Truthy, Falsy, and Conditional Flow. It kind of gives you a good exercise on those, especially this Conditional Flow one. I think this one's pretty cool. I think this is the one. Yeah, this is the one that has a bunch of nested if statements, and you have to think about how can you get there to congrats? How can you do that with the input you have, or which one of these is going to get you to that input? And so it kind of it guides you through it. So this is like taking the if and else thing to the extreme, you know, when you're looking at how to write, and you see logic trees like this in code. So understanding how these work is pretty cool. So you have the weekend. So again, we'll come back Monday and we'll go over lesson 4. Lesson 4 is going to be Python ordered data structures. So we're talking about lists, we're talking about tuples, and the methods we use with them. So I'm still going to be here for the next 10 minutes. So if we have any other questions or anything, I am going to switch to my earphones because I have another storm coming through and it's pounding my window and I can barely hear. Hold on. Give me a second to stop the recording.